For this example, we're going to factor. For this first one, we have 26x to the fourth plus 6x to the fifth minus 20x to the third. When you do factoring, it is assumed that the polynomial is in standard form. This one is not, our highest power of x is not the first term, so to start with, we will need to rearrange to put this into standard form. Then from there, we would want to take a look and see if we have a greatest common factor. Our coefficients have a common factor of 2 there. That's the greatest numeric common factor. And then all of them have an x. The lowest one is x to the third. So a 2x to the third would be our greatest common factor, and we should factor that out in front. If you divide each of these terms by a 2x to the third, we end up with 3x squared plus 13x minus 10. From there, we want to see if we can factor what's inside the parentheses. There's 3 terms there, so I'd want to go through and attempt the add multiply method. For this problem, I'd be looking for 2 numbers that add to be positive 13, and when you multiply them, give you 3 times negative 10, which is a negative 30. There are 2 numbers that fit that pattern. They are negative 3 and negative 10. Just kidding. Those are the wrong numbers. You could try those, but they don't fit the pattern. Let's try positive 15 and negative 2 instead. If I multiply those, I do get negative 30. If I add them, I do get 13. All right, so there's our numbers. I can't use the shortcut because of the 3 in front of the x squared term, so I'm going to copy that term down. This x term, I'm going to split apart using these 2 numbers. It's an x term, so when I split it apart, it would have to be a positive 15x and a minus 2x. Then copy that last term down again. Then from there, we can take a look at the 2 groups that we have and do some more factoring and see if we get matched parentheses. These first 2 terms do have a 3x in common. These last 2 terms have a 2 in common. I could factor out a positive or a negative 2. I'm going to factor out a negative 2 this time because the first term in this last group has a subtraction in front of it. When I do that, I do end up with matched parentheses. So the trinomial factors into a matched set of parentheses and then what we pulled in front. Remember though that we did some factoring earlier on. All this represents is the factoring of this set of parentheses here. This 2x cubed really was sitting out in front of each one of these steps. So don't forget, if you factored out a common factor, to include that as part of your final answer. For letter B, we are going to factor 4x cubed plus 12x squared minus 9x minus 27. First step is to factor out what's in common. There's nothing in common. Counting the terms, I do see we have 4 terms. So I should give factoring by grouping a try. The first 2 terms have a 4x squared in common. The last 2 terms have a 9 in common. I could factor out a positive or a negative. First term in the last group is negative, so I'm going to factor out a negative 9. I did get matching parentheses. So that does factor into an x plus 3, our matching parentheses, and then a 4x squared minus 9. Typically, we tend to be done at that step, but there are problems where you can continue to factor these further, so we should check that. X plus 3 is a two-term polynomial. Doesn't fit any of our rules for factoring two terms. 4x squared minus 9 does, though. Both of these are perfect squares, and we have subtraction in between. So using a difference of squares pattern, we will be able to factor that last set of parentheses one more time. When you factor using difference of squares, you get two binomials. The reason 4x squared is a perfect square is because that's a 2x times another 2x. 9 is a perfect square because that's 3 times 3. And then we need alternating signs. We should check and see if any of these factor again, but they don't fit any of our rules this time, so this is our final answer.